And now let's look at example number 5, where we're gonna find the inverse of somehow a little more difficult function here. So we still want to find the inverse. Okay, so now my function that I'm looking for the inverse is going to be 7 over x minus 3. So once again, all the steps gets repeated again. And here at step number 1, I need to replace my f of x symbol on the left hand side of the equation here by the variable y. And here my equation would become y equals 7 over x minus 3. And this is the end of step number 1. And now my next step here would be to interchange the x and the y, to interchange the role of the x and y. So here in my equation, supposedly y would become x on the left hand side and x would become y on the right hand side. So I have x equals 7 over y minus 3. And this is the end of step number 2. And once again, step number 3 now is ready to move on. We need to solve for y here. And so first off, I need to add 3 to both sides of the equation. And that gives me x plus 3 equals 7 over y. And now to solve for y, at this point here, I leave the options for you. There are quite a good variety of ways to have to solve for y from here. But I find it shortest for me is to take the reciprocal equally on both sides. Think about the x plus 3 quantity on the left hand side here as a fraction x plus 3 quantity over 1. And so here I have a ratio equals a ratio again. So to solve for y, I can just simply take the reciprocal side by side. So here I'm going to have y over 7 equals 1 over x plus 3 on the left hand side. And now finally, to solve for y, all I have to do is just multiply both sides by 7. And that's going to cancel with the 7 on the right hand side. And that gives me y equals to 7 over x plus 3. And at this point, I can once again, just like before, we can simply rearrange the equation by turning the sides around. So I have y equals 7 over x plus 3. And once again, if you check to decide which one is to be the inverse function. Now check on the right hand side. And what I'm seeing here is there's only one expression. It could be a large expression, but there's only one expression. And all that here equals y. So my inverse function now is decided to be, and here's my function f inverse, f negative 1 power of x. That's the notation for the inverse. So f inverse equals to 7 over x plus 3. And here is the final answer to my example number 5. How about another example here? So example number 6. We want to find the inverse again. Find the inverse. So my function at this point is having f of x equals to the square root of x minus 5. Okay, so here's the function I have. So now once again, to find the inverse, step number 1 is to replace the f of x symbol on the left hand side with a y. So my equation would become y equals to square root of x minus 5. And once again, that is step number 1. Step number 2 now is to interchange the x and the y. To interchange, so x becomes y, y becomes x. So my equation would look like this. X equals square root of y minus 5. And that is step number 2, interchanging the variables. And step number 3 is now to simply solve for y. And at the beginning of the semester, or in the other videos, I already showed you how to solve the equation that involved the square root here. So the only technique that we have here is to square both sides. And so here what I have is on the left hand side it becomes the x squared because I'm squaring the left hand side, and at the same time I'm squaring the right hand side. However, squaring the right hand side would means we're going to cancel away the square root. So here the right hand side would become y minus 5. And so to solve for y, furthermore, to solve for y, all I have to do now is adding 5 to both sides. And that gives me x squared plus 5 equals y. Or you can rewrite the equation as y equals x squared plus 5. And that is all that here. Those are the steps for step number 3. So now what we're doing next is to decide the expression for the inverse function. So now if you check with the final equation that we have just ended up right here that I underlined, there's only one expression, and even though it can look like a large expression, but there's only one expression equal a variable y. So now I can safely assign that expression x squared plus 5 on the right hand side to be the inverse function of f that we were looking for. So here's the final answer. We want to find the inverse, f to the negative 1 power. So now it's time to look at some specialized version of these finding inverse problem. Example number 7. We want to find, and by the way, instead of keep saying find the inverse, I'm going to use the notation find f to the negative 1. So now keep in mind, I've discussed this in class, but f to the negative 1, that's the symbol for the inverse function. And the function that we're looking for here is f of x itself. The original function that we're now gonna look for the inverse is going to be let's say x squared minus 1, and here I'm going to go x greater than or equals to 0. And so here we would like to find the inverse. Okay, inverse of f. Okay, so here I'm giving you the function f of x, which to be x squared minus 1 common. And then so now if you're looking at this problem, we're gonna be at first you're gonna feel shocked that this problem, it seems like it's a repeat of example number 4. However, if you pay attention a little closer, there's the x greater than or equals to 0 here as a condition. This is the part that's unlike with example number 4 we had earlier. Now once again let me remind you, in example number 4, the exact same function we worked our way through, and we found that there's no inverse. But here, what's the idea with that little condition coming along here? So let me show you. Once again, the steps are going to get carried over again. I'm going to need to replace the f of x here by the variable y, and that is going to give me y equals x squared minus 1. But keep in mind, the conditions keep coming along. So here, in any steps, we always need x greater than or equal to 0. Now in these steps, pay attention, in these steps, the condition here is not playing much part of it yet. However, later on, that condition is going to be what helps you to determine the actual inverse of the function. So now, the next step is back to the equation. The next step here is to interchange between the x and the y. So my equation would become x equals y squared minus 1. But now pay a little more attention also on the conditions. Since like I said earlier, we interchange x and y, so x become y. So now in my conditions, initially it's supposed to be x greater than or equal to 0. Now it's going to become y greater than or equal to 0. And once again, what's the reason for that? We interchange x and y. So x becomes y and y becomes x. So now in any step that I'm moving along, there's that condition that involves the x. So now the x has to be changed to the y. And now the next step is to solve for y. So solving for y, and you should have known how to do this by now. Adding 1 to both sides, and that gives me y squared equals x plus 1. And the next step here is to take the square root. So now just like what we did in example 4, I'm going to end up with 2 square root on the left hand side, x squared plus 1, or underneath the square root with a plus and minus in front. Or rearranging the equations, rearranging my final equation. So far, I'm going to have y equals plus and minus square root of x plus 1. And keep in mind that conditions keep coming along. Now, the question here is, how can I decide? Remember, everything up to this point is just like example 4. Except for these conditions that coming along. That's the only part that's make it unlike example 4. So now, in example 4, right at the step, we were saying that there's no inverse function. But in this problem, since the little condition is saying something about choosing the little y greater than or equal to 0 over here, the condition is something that helped me to decide which one. Keep in mind, like I explained earlier, y equals to this expression right here, the equation that we're having here. On one hand, it equals to y equals to positive square root of x plus 1. And on the other hand, y equals to minus square root of x plus 1. Okay, so now to help you to decide, remember here we have 2 different expressions. So which one of these is going to win the battle to become the inverse function? The answer is there. So now what I'm going to try is think about, you choose any value for x. So you don't have to sweat out by choosing an x value. Choose any x value. That's your choice. So here I'm going to choose x equals 0, for example. Okay, so now I'm going to plug 0 into both expressions, and I'm going to try to find out which expression is going to give me a positive y value. So now choosing x equals 0. On this left side, I'm going to have y equals positive square root of 0 plus 1. And that gives me y equals to positive square root of 1, which gives me y equals positive 1, because square root of 1 is 1. So that's what I have so far. Now on the other hand side, I'm going to do the exact same thing, but I'm using the different expressions for x. So here I have y equals minus square root of 0 plus 1. And once again, why am I doing 0? Because I chose the value for x to be 0. And you, on your own work, you have your own choice to choose a different value for x. And here I'm going to have minus, so y equals minus square root of 1. And that gives me, and minus square root of 1 equals to minus 1. So now, on this left column right here, my y value that I computed using an arbitrary chosen x value, x to be equal to 0 over here, I ended up with a positive y value. And here I ended up with a negative y value. So which one here, these two answers for y, these two values for y, which one is consistent with the conditions specified earlier? So here, this condition is saying that we want the y positive or equal to 0. So now that means this side is the winner. Meaning, here's at the final line, deciding my inverse function in this case is to be positive square root of x plus 1. And that is the whole point of what we're doing here. So this type of problem, we're calling that finding inverse. We're trying to find the inverse of a function in a restricted domain. Now this here is we're calling that a restricted domain. Okay.